October 19, 2017. A faint flicker on a monitor in Hawaii. Something was moving through our solar system, faster than any comet, stranger than any asteroid. It didn't belong here. It came from the absolute dark between the stars, a traveler with no name and no home. The world called it Oumuamua. This is Part 1. Part 1, The Silent Intruder. The universe is not just big, it is silent. A crushing, absolute silence that stretches across light years. For centuries, we have looked up at the flickering points of light in the night sky and wondered if anyone was looking back. We have built great monuments, sent radio waves into the dark, and launched golden records on the voyages, hoping for a reply. We have spent decades listening, waiting for a signal, a beep, a digital pulse, a greeting. But we were looking for the wrong thing. We were looking for voice, when we should have been looking for shadow. A shadow that moves through the dark, not with a message, but with a purpose we might never understand. A silent traveler that does not care about our greetings or our existence. The story begins on October 19, 2017. The island of Maui, Hawaii. On the slopes of Haleakala, the Pan-STARRS telescope was performing its silent, rhythmic duty. This is the guardian of Earth, a machine designed to scan the black canvas of the sky for threats, asteroids and comets that might one day cross our path. It is a world of data, of pixels, and of cold, mathematical certainty. Robert Werrick, a researcher at the University of Hawaii, was reviewing the overnight results. Among the thousands of known objects, there was a speck, a tiny, unremarkable dot of light. At first, it looked like just another rock from our own backyard. But as Werrick plotted its course and checked it against the data from the previous night, the air in the room seemed to get colder. This object was not orbiting the sun. It was not bound by our gravity in the logical way a local asteroid should be. It was traveling at a staggering 87,000 kilometers per hour. It had come from above the plane of the planets. It had come from the direction of the constellation Lyra. It had crossed the immense, frozen no man's land between star systems. For the first time in human history, we were looking at something that did not belong to our sun. It was an interloper, a ghost from the interstellar void that has been traveling for millions, perhaps billions of years. The scientific community felt a jolt of electricity. They named it Oumuamua. In the Hawaiian language, this name translates to a messenger from afar arriving first. A scout, a pathfinder sent out from the dark. But a scout for what? And why did it wait until it was already leaving us to be noticed? By the time we found it, Oumuamua had already passed its closest point to the sun. It had already made its turn and was accelerating back into the dark. We had a window of only a few weeks to look at it before it vanished into the abyss forever. It was like catching a glimpse of a tall stranger in a dark hallway, just before they turn the corner and disappear into the night. We were desperate for answers, but the visitor was in a hurry. As the world's most powerful telescopes, the Hubble Space Telescope, the Spitzer Space Telescope, and the Very Large Telescope in Chile, turned their massive lenses toward the visitor, the confusion only grew deeper. Usually, when we see a visitor from the outer reaches of space, it is a comet, a ball of dirty snow and frozen gases. As a comet nears the heat of the sun, the ice melts, creating a glowing tail of gas and dust. A bright, visible look at me sign that spans millions of miles. But Oumuamua had no tail. There was no gas. There was no dust. Even under the most sensitive infrared cameras, It was surgically clean. It was a solid, dark, inert object that refused to bleed even a single molecule into the vacuum. This was the first anomaly. A comet that was not a comet. A rock that did not behave like any rock we had ever seen. Then came the analysis of the light curves. Most objects in space are roughly round or lumpy like potatoes. But as Oumuamua tumbled through space, its brightness changed dramatically every few hours. It would brighten, then dim, then brighten again by a factor of 10. This meant the object was extremely elongated. It was at least 10 times longer than it was wide. Imagine a dark, reddish, needle-shaped object, 400 meters long. A skyscraper-sized needle floating horizontally through the void, spinning slowly in the eternal dark like a discarded relic. Nature does not easily make needles. Nature does not make 400-meter cigars. In the vast, chaotic randomness of the cosmos, Oumuamua did not look like an accident. It looked like a design. A deliberate, aerodynamic form designed for the long journey through the dust of interstellar space. Where did it come from? That is the question that haunts every astronomer who saw the data. To travel from the nearest star systems to our own takes tens of thousands of years at those speeds. Oumuamua has been drifting through the frozen, radiation-filled vacuum for eons. It has seen the birth and death of stars we will never see. It has survived the intense gravitational tides of binary systems and the explosive shocks of distant supernovae. It has spent millions of years in a temperature of minus 270 degrees Celsius. And yet, it arrived here, in our small corner of the galaxy, at this exact moment in our history. It is a coincidence so massive that it feels almost intentional. A message sent into a bottle, drifting across the cosmic ocean until it finally washed up on our shores. But the shape was not the biggest mystery. The real shock came when the scientists measured its speed again as it moved away from the sun. Gravity is a strict and unforgiving master. It dictates exactly how an object should slow down as it leaves the sun's powerful grip. But Oumuamua did not follow the laws of Newton or Einstein perfectly. It pushed. Something was giving it an extra kick. A non-gravitational acceleration that defies standard explanation. In a normal comet, outgassing would explain this, like a natural rocket engine made of melting ice. But as we established, there was no gas. No dust was detected by our most sensitive instruments. No infrared heat from a melting core was visible. If it was not a comet, and it was not a simple rock, what was providing the thrust? What was the source of the energy that pushed this needle-shaped shadow away from our sun? The world of professional astronomy is usually a place of quiet calculations and long, patient observations. But in the weeks following the discovery, that peace was shattered. This was not just another discovery. It was a race against time. Every hour that passed, the object was moving further away, fading into the background noise of the universe. To understand what we were looking at, we had to push our technology to its absolute limit. The first major challenge was determining the color of the object. When the Very Large Telescope in Chile captured its first clear images, the data suggested a dark, reddish hue. This was not the bright, reflective red of a fresh apple, but the deep, bruised crimson of organic molecules that had been baked by cosmic radiation for millions of years. This color is a signature of the interstellar medium. It tells a story of a journey so long that the very surface of the object has been chemically altered by the relentless bombardment of high-energy particles from distant stars. But as the data grew, so did the contradictions. A team of researchers tried to find evidence of heat. If Oumuamua was a natural rock, It should have absorbed some of the sun's energy and radiated it back as infrared light. The Spitzer Space Telescope, our most sensitive eye for heat, pointed toward the visitor for 30 hours. It saw nothing. The object was so small, or perhaps so strange in its composition, that it left no thermal footprint that we could detect. This lack of heat emission set a strict limit on its size, making its elongated shape even more baffling. If it was as small as the data suggested, how could it be so long and thin without breaking apart under the stress of its own rotation? This rotation, or tumbling, was another piece of the puzzle. Oumuamua was not spinning gracefully like a planet. It was chaotic. It was tumbling out of control, like a ship that had lost its engines and was drifting at the mercy of the currents. Scientists calculated that this tumbling state was stable, meaning the object had been moving this way for billions of years. It was a frozen moment of chaos, preserved in the vacuum of space. Every time it turned, it reflected a tiny bit of sunlight, creating the flickering light curve that first told us its shape was like a needle. Then, the debate shifted to its origin. If it came from the direction of Lyra, which star was its home? Astronomers traced its path backward through the galaxy, accounting for the movement of all nearby stars. But they found no perfect match. It did not come from any of the star systems currently near its path. This means Oumuamua is likely a true wanderer, an orphan of the cosmos that was ejected from its home system during its violent birth, billions of years ago. It has been traveling through the empty space between stars longer than Earth has even existed. Think of the sheer scale of that journey. Before the first dinosaurs walked our planet, Oumuamua was already in the deep dark. While our ancestors were discovering fire, it was silently passing through the gravity wells of nameless stars. And then, in 2017, it finally arrived here. We were the first eyes to ever see it. Nor as soon as we looked, it began to slip away. The frustration among scientists was palpable. We had the greatest mystery in history right in front of us, but we were looking at it through a keyhole. As the object crossed the orbit of Mars and headed toward the outer solar system, the non-gravitational acceleration became undeniable. This was the moment the alien hypothesis moved from science fiction to a serious mathematical possibility. If nature could not explain the push, then we had to look at artificial explanations. Was it possible that the object was reacting to the sun's light? Not because it was melting, but because it was designed to. In the quiet offices of the world's elite universities, some whispered the word alien. Most scientists in the mainstream hesitated, fearful of their reputations and the laughter of their peers. Nor in the prestigious halls of Harvard University, Professor A.V.A. Loeb looked at the raw data and saw something that others refused to see. He saw a sail, a light sail, a piece of technology so thin, so light, and so vast that the mere pressure of sunlight itself could push it through the void. A mirror reflecting the stars, carrying its cargo across the ocean of space. It was a theory that shook the foundations of astronomy. Think about the implications of such a thing. While we were arguing about our borders and our small wars, while we were sleeping in our warm beds, while we were living our small, fragile lives, a relic from another civilization might have drifted through our backyard. Was it a piece of space junk from a star system that died 1 billion years ago? A discarded fender from a celestial machine? Or was it a functioning probe, eyes wide open, quietly scanning our planet, our atmosphere, and our technology as it passed by? We tried to listen for signals. We pointed the Allen telescope array at the object, hoping for a hum, a pulse, or a digital heartbeat. We searched for any sign of a transmission. Nor there was only silence. Oumuamua did not want to talk. Or perhaps we were not worth talking to. Perhaps to a civilization that can build machines that survive millions of years, we are nothing more than ants on a pebble, too primitive to even acknowledge. We were like a tribe in the jungle watching a high-tech drone fly overhead. We saw it, but we had no way to communicate with it. The frustration of the scientific community was not just about the lack of data, it was about the lack of time. When we realized that Oumuamua was moving away at such a high speed, a group of engineers and dreamers proposed something radical. It was called Project Lyra. They asked a simple but terrifying question: can we catch it? Even now, as it fades into the dark, can we build a machine fast enough to overtake this visitor and look at its face? To do this, we would need to use technology that exists only on paper. We would need a nuclear thermal rocket, or a massive solar sail that would dive close to the sun to gain incredible momentum. We would need to launch a chase that would last for 20 or 30 years, sending a probe into the empty space between stars where no sunlight reaches. It was a moment of realization for our entire species. We have the technology to destroy our own world, but we were not ready to follow a single guest out of the room. This missed opportunity changed the way we look at our own defense systems. NASA and other space agencies began to rethink the importance of rapid response missions. If another Oumuamua appeared tomorrow, would we be ready to launch a camera within weeks, or would we simply watch another shadow slip through our fingers? We began to look at the sky not as a static painting, but as a busy street where we are the only ones standing still. Think about the sheer loneliness of Oumuamua. If it is a natural object, it has been alone for billions of years, a cold fragment of a world that no longer exists. But if it is artificial, it is even more haunting. It would mean that out there, in the vastness, there are things that move with intent, objects that serve a master who might be long dead. It makes our own achievements, our cities, our history, feel incredibly small. We are like children playing in a sandbox, while the adults pass by on the sidewalk without even looking down. As we watched the light from Oumuamua flicker one last time, we felt a shift in the collective consciousness of Earth. The debate between Loeb and his colleagues was not just about physics, it was about hope and fear. To find a rock is science, but to find a sail is a revelation. It would mean that the Fermi paradox, the question of where everyone is, has finally been answered. They are here, or they were here, and we simply were not looking. This was not just an astronomical event. This was a wake-up call for the human race. A reminder that we are part of a much larger, much older, and much stranger story. The story of Oumuamua does not end with its departure. It is only the beginning of our search for the architects of the dark. As the intruder fades into the black between stars, we are left staring at the spot where it used to be. Waiting, watching, because if there is a first, there will inevitably be a second. And next time, we must be ready to catch it. We must be ready to face the truth of what lies in the deep. By the end of 2017, Oumuamua became a faint smudge on our most sensitive senses. By 2018, it was invisible even to our strongest eyes. It is currently heading toward the constellation Pegasus, accelerating back into the deep interstellar sea where no human eye will ever see it again. It is gone forever, leaving us with nothing but a handful of data points and a profound sense of loss. We are left with more questions than there are atoms in a grain of sand. Was it a natural anomaly we do not yet understand? A hydrogen iceberg or a nitrogen fragment from a distant Pluto-like world? Things we have never observed in our own system. Or was it the first time we were truly visited, and we were too slow, too blind, and too arrogant to say hello? The visitor is gone. The hallway is empty again. Nor the silence. The silence feels different now. We are no longer alone in our thoughts. We know, with mathematical certainty, that the void is not empty. It is a highway. And we just saw our first traveler. Everything we thought we knew about our place in the cosmos has been challenged by a single, dark, tumbling needle. If one can visit us, how many more are out there? How many scouts have passed through our system while we were still huddling in caves? How many are passing through right now, just beyond the reach of our current technology? This was not just an astronomical event. This was a wake-up call for the human race. A reminder that we are part of a much larger, much older, and much stranger story. The story of Oumuamua does not end with its departure. It is only the beginning of our search for the architects of the dark. As the intruder fades into the black between stars, we are left staring at the spot where it used to be. Waiting, watching, because if there is a first, there will inevitably be a second. And next time, we must be ready to catch it. We must be ready to face the truth of what lies in the deep.